Hello, everyone. Good afternoon, and welcome to this session. My name is Harshal Pimpalkate. I'm a senior product manager with Amazon Lex. In today's session, we want to walk you through how you can use Amazon Lex to integrate with an interactive voice response system, also known as a IVR. And specifically, we want to cover how Genesis has integrated with Amazon Lex to provide this solution. And with me on stage, I have today Jack Nichols, the Director of Product Management, Genesis, and Darren, he's from eMite. The eMite is using this solution. So we're going to cover the architecture. We're going to talk about what problems it solves and some of the underlying mechanisms. So I'm sure all of you have had this experience. You call up your bank, and the voice on the other side goes, press or say 1 to check your bank balance. Press or say 2 to order checks. And this goes on for like 9 options. And by the time you're on the 9th option, you've forgotten what the first option said. This is an experience that we are trying to improve on. Wouldn't it be great if you could just, using natural language, tell the voice on the other side what is it that you really want to do? So for example, if you could just say, hey, I want to check my bank balance. And sure, the voice on the other side goes, yes. Is it checkings or savings, and so on. So that's exactly the interaction that we're trying to accomplish using Amazon Lex and Genesis Pure Cloud. So with that, let me jump in and provide you with a quick overview of what Lex is. We launched this service a year ago at reInvent. It's a service that you use to build conversational interfaces, also known as chatbots, using voice and text. It's powered by the same technology as Alexa. So we use the same speech recognition and natural language understanding stack as Alexa. As you might be familiar, these are some of the most complicated problems in computer science today. You need knowledge of sophisticated algorithms. You need access to massive amounts of data. You need access to a lot of infrastructure to implement something like this. With Lex, we are putting the power of Alexa in the hands of developers. And by doing so, we're essentially democratizing the deep learning technologies. So that's what Lex is. It's a complete solution. So you can convert from speech to text. So we have a speech recognition engine built in. Also, we have dialogue management, and I'll talk a little bit more about this. You can engage in a dialogue with the end user. So you can have a multi-turn conversation where you elicit information and then fulfill the goal of the conversation. Our philosophy is you should be able to build once and deploy multiple times. So you build a bot for, let's say, for speech. You should be able to deploy it on a different modality, let's say text. Also, you should be able to deploy it on multiple platforms. So you can start off with mobile, but you should have it on, or you should have the capability of deploying it on Facebook, Messenger, let's say Slack or Twilio, or most recently Kik. So that's the deployment piece. Lex is a completely managed service, so you don't have to worry about scaling it as your demand goes up. We do that for you. It's a fully managed, scalable service. Also, we natively integrate with AWS Lambda. So if you want to implement your validation logic or any kind of business logic, or even the fulfillment piece, that can be implemented using AWS Lambda. Third, or the next piece is the security. We encrypt the user utterances in transit and at rest. Also, we provide analytics, so you can track the user utterances as they're coming through the system. You can track the number of text requests, the number of speech requests. You can monitor utterances that are not recognized by Lex for whatever reason. And you can use these utterances to figure out ways to improve your chatbot over a period of time. And finally, we have text-to-speech, which is inbuilt. So we natively integrate with Amazon Polly, which is another AWS service. We natively integrate with Amazon Poly to convert any responses that are going out from the chatbot to the end user from text to speech. So that's Lex in a nutshell. Now, what does an interaction look like? Let's use an example. Let's say a user wants to book a hotel, and the user says, book a hotel in New York City, and this is speech input. Lex will convert this to text using the speech recognition engine. So the sentence is converted to 5 words, book a hotel in NYC. Next, Lex will apply the natural language understanding models to figure out the intent of the spoken words. In this case, the intent was hotel booking, and there was some important information that came along with it, which was the name of the city, the New York City. And that's also gleaned from that user utterance. Over the next few turns of the conversation, Lex engages in a dialogue and figures out other information. For example, check-in date, checkout date, or the room type, and it gets that information and prompts for confirmation. So it prompts, can I go ahead with the booking? The user says yes, and then the transaction is fulfilled. So that's a sample interaction. You can make this as comprehensive as you want. This is just a simple example to give you a sense for what a Lex conversation looks like. Now, how do you build such a chatbot? Before I talk about that, I want to take a quick moment to describe some terminology. So when you engage in a conversation, typically you want to meet some goals. So let's say you're booking a trip. You may want to book a hotel. You may want to book your flight tickets. You may want to book your car rental. So right there you have 3 goals. These goals are what we call intents. And what you see here is one such intent, the book hotel intent. Now, to express this intent, the user might say or type certain phrases. So they might say, I want to book a hotel, I want to make a hotel reservation, or I want to book a room. And these are what we call sample utterances. So we take these sample utterances from the developer and build a language model. And that's how the language model comes to be, based on the developer-defined utterances. Next, as the conversation evolves, you need information to fulfill the intent. So for example, in case of booking the hotel, you need the check-in date, checkout date, and that's what we call slots. And slots are the pieces of information necessary to fulfill the intent. And finally is the fulfillment itself. So you can either have a server-side fulfillment through AWS Lambda, or you could have a client-side fulfillment if you return all the parameters to the client. So that's some terminology. Now let's take a quick look at how you would build such a bot. Here, first you define the sample utterances. And we typically recommend that you provide like 15 to 20 sample utterances. And those are sufficient for us to build a language model. You don't have to provide an exhaustive list of all the different possible combinations. 15 to 20 is sufficient, and that allows us to extrapolate to match to a variation of one of the sample utterances if the user doesn't say something exactly the same. Second, you define the slots, the pieces of information that I mentioned earlier. You define the location, you define the check-in date, the number of nights you want to stay, and also the room type. Quick call out over here. Lex provides something called predefined resources, or what we call built-in slot types. And an example here is the city. So when you're defining your location, you can use amazon.us city to define the slot type. For number of nights, you can use amazon.number. And think of these as curated set of, think of this as a curated set of data. So curated list of cities that you can select from as you define your language model. At the same time, you can also have your own custom slot types. For example, room type values. And you can have king, queen, or deluxe in there. So a custom slot type is also doable at the same time. Next, you define the interaction with the bot. So you define the prompts to elicit information. And here, these are a set of questions. What city will you be staying in? Or how many nights will you be staying? And so on. You define prompts to confirm the transaction. So I have you for so many nights at this city, checking in on a certain date. Can I go ahead and make the booking or the reservation? So that's the confirmation prompt. And finally, the fulfillment. So you can fulfill, like I said, on the Lambda, or you can return the parameters back to the client. So that's Amazon Lex in a nutshell. And I want to invite Jack to the stage. And what Genesis has done is they've taken Amazon Lex and integrated it into a pure cloud contact center solution. And Jack is going to describe the details over here. Jack.
Awesome. Fantastic. Well, thanks, Harshal.
Thanks.
So, like I said, Harshal introduced me. My name's Jack Nichols. I run a product team focused basically on building custom solutions with our joint partners such as Amazon. So we try to understand what our customer needs are and things outside of our platform, and then we work with our partners to build things out. So there's me. I work for a company called Genesis. If you're in the contact center space, you probably know who Genesis is. But if you're not, the high level is we are the market leaders in the prim and cloud world. Pretty much if you've called a major company, you've probably been on one of our customer service solutions in the back end, working with a company, whether it be through email, through web chat, through social. But more importantly, today I want to talk about Pure Cloud. So Pure Cloud is the solution we integrated with Lex. And Pure Cloud was born about 2.5 years ago. We went GA. And it was actually a complete rewrite in the cloud. So complete microservices architecture written on top of Amazon, basically to allow us to scale. So it is cloud first, API first, all in the cloud, which actually made the integration with Lex a lot easier. So before I go any further, kind of wanted to, what are we trying to solve here? One of the nice part is everyone in this room has probably had a bad customer service experience. I know I've had lots of calls. I have 2 young children that run around in the background. So if anything's ever looking for words, it picks up some of the more interesting words that are probably said in my house at different times. So we've seen this, and we've seen more and more technology come out, but it still has some limitations, as Harshal kind of mentioned earlier. So just for those that aren't familiar with it, I wanted to walk through a little bit of the evolution of some of the IVR technologies that have been out there, and what are the challenges with it? What are we actually trying to solve here? So if you actually go back early days to Bell Labs, they came out with DTMF actual signaling. So if you think about it before, it used to be, and we've all seen the pictures of the huge switchboards and the people actually working there. So if someone called in, they answered it and they had to transfer the call. But when we came out with DTMF, it allowed us to start saying, press 1 for sales, press 2 for support, and at least start to get customers to the right division within a company. So they didn't know exactly where they're going, but it got them a little bit closer. From there, CTI, or computer telephony interfaces, started emerging. So now we could take information from the DTMF that was input along with other data sources, and we could start to put that together and start to figure out, okay, well, they want to go to support, and it's for this product. So I can start to get a little bit more close to where I actually need to put a customer to solve their problem. And then we started seeing more and more keyword recognition. We've all had that. We've all had the old days when, say your social security number, for your bank account and those kind of pieces, where if you got one number wrong or it picked up some in the back, it had challenges. So it was another leap forward because it gave us more options than 0 through 9, but it still had some limitations. And what we see is we see natural language understanding really kind of being the next evolution of IVR-based technology. And it's really for a few reasons, and Harshal mentioned a few of them earlier, but really, one, I always look at my kids, they have Alexas, and they're used to talking to things now. When the iPhones first came out and they were 2, they'd go up to a screen, and if it didn't react, they got really, really upset. Now they're starting to get the same way about the voice. Pretty soon they'll be talking to their toothbrush, I'm pretty sure, trying to make sure it tells us they brush their teeth. So everyone's getting more and more used to those telephony, those voice interfaces. The other thing for contact center specifically, natural language understanding, we've got all these channels that are emerging. So whether it be web chat, whether it be voice, whether it be whatever the newest social media is. I'm not up to date. I was just in Japan, and LINE's a huge thing there. but call centers are just trying to keep up with all that. So using natural language understanding, we start to be able to apply a single conversational flow across any of these. So I don't care what new social media platform comes out, I can take that and I can apply it across and make it really easy to continuously adopt new technology. So one of the things for Genesis, one of the big areas that we kind of focus is what we call blended AI. So when we look at things such as Lex, we look at what's going on, we see a really big benefit of figuring out how to blend AI with humans. So if you think about a chatbot, we've probably all used them online. There's certain limitations. There's certain things that it can do really well. There's certain things that it doesn't need to do very well. So with Lex, one of the things we wanted to build right from the beginning was, hey, if Lex can't solve this, we want to be able to have Lex pass an interaction off to an actual human. So if someone gets on, because there's nothing worse than when you're trying to chat with something and it doesn't solve your problem and it just keeps telling you, I don't understand, I don't understand. It just tends to piss you off a little bit. So what we want to do is make sure that if a bot can't solve a problem, that it can hand off to a human. And then we also want to be able to take all that data on the bot's performance and the human performance and pull it together. Because if you think about the AI technology such as Lex, we all want to look at how's that performing. Is it making customers happy? Is it not making customers happy? Is it passing off the data appropriately to the customer? Is it passing off to the agent when it should? So we want to make sure that all flows into a single common interface. And then really it goes back into then using that to educate. So whether it be a human having to take a new class to learn more about a technology, whether it be a bot that needs to have more sample utterances given to it so that it can understand and do more, and feed that right back into that loop. So our premise is that as we keep doing that over and over, that cycle will just continuously make the bots better. It'll make the humans better. It'll make sure that the customers have a good experience. And that brings us to Lex. So when we looked at talking with Harshal a few months ago, we really saw the benefit of Lex to actually, one of the big things for us was to democratize being able to make AI available to contact centers. Our solution solves contact centers from 20 agents to we have thousands of agents. But when you look at certain things like natural language understanding, it's really expensive to get started. A lot of companies are scared to do that. It's a huge investment right up front. With Lex, it made it very easy. I mean, we'll show an architecture here of a call flow in a minute, and we were able to set that call flow up in a matter of less than a day using Lex, something that before would have cost about $1 million in 3 months just to get to the place we got within 24 hours. So it's a really big thing, and that simplicity is also huge because everyone talks about wanting to use this, but then they get scared when you start talking about how to get to it, and how to use it, and how to leverage it. So one of the things that we liked about Lex was it's very, very simple from that perspective. Okay, so I'm going to talk a little bit about technical architecture because I am in product, so I'm ready to talk tech. So this right here is a high-level architectural diagram of how we've actually integrated our media in with Lex to date. And I'll actually walk through a flow and show how data actually flows through all the services. But some of the key things here is we actually have multiple VPCs that run our technology, from our core services to our media VPC to a customer's own Lex instance so that they can pull bots back and get information. We also have a carrier VPC where we actually run our own interconnected VoIP. So we can bring all that together, and we can also segment that data so that when you look at things like compliance in the US, you look at things like GDPR in Europe, that we can sufficiently support those models. And again, I'll walk through this and show an actual diagram of how data actually flows through this. But before I do that, so the demo we're going to show here in a minute is a use case for our good customer and partner, eMite, and how they want to be able to implement Lex to manage some of their support pieces. So this is just a high-level representation of the call flow. We'll go more detailed here. But if you think about it, the way it works today is a call comes in, and when that call hits an 800 number or there's a local DID2, it's immediately going to look at the ANI of that call. It's going to dip that against a a Zendesk instance and verify if that user is a known user or not. If it's an unknown user, it's going to prompt them to put in their phone number and try to match them if it can before we pass it off to the bot. We want to make sure that we have a validated users before we start passing things over to the Lex service and having them do all sorts of fun stuff. Once we've validated the user, we'll pass that off to the bot, and we'll have the bot try to determine what the intent is, understand the right slots it needs to populate to pass that data back to PureCloud. And then based upon what we get from the bot, it'll actually pass back, and then we'll execute the rest of a call flow. And again, we're going to walk through the configuration of this in a little bit, and I'll actually show, because I'm in product, so I don't like slideware. I like to actually see things working. So this is a actual representation. So that last call flow was the high-level flow. This is actually how it's working through our services. So when a customer comes in and they publish a new call flow that's using Lex services, it's going to push a VXML file down to what we call our edge services, which is where it keeps the customer-specific logic on how to manage their calls, how to manage their flows. Once a call comes in, then it's going to terminate into our telecom group. So we'll have the SIP and RTP will come in there. It'll look and say, oh, well, this needs to go to customer XYZ. And it'll actually take the SIP down to the customer's specific edge instances, and then it'll park the media on our media tier that's going to be able to do all the processing and bring all the audio out. Once the edge services determines who that is, what it should be doing, it's going to communicate with the media tier to tell it, hey, accept this call, and here's how you need to go about processing that call within the media services. It's then going to synchronize everything about this interaction up to what we call our conversation services. So we know all about the state, we know what it's doing, we know what's going on for analytics. So it's going to continuously update that throughout the rest of the life of the call. Then if the media services says, hey, I'm supposed to send this off to Lex, we actually have an integration services that he will reach out to. So Lex will the media services will reach out to the integration services and say, hey, I need to access Lex. I need the credential information to be able to pass this call off to the Lex service and what bot I should pass it to. We then actually establish a REST connection into Lex with a 16-bit audio stream that goes into Lex, which is how we actually get the intent, the slots, and then that data is passed back to Pure Cloud, which into our media services, which then is synchronized back into our edge services. At any point, if in the flow we have, if a customer says emergency, we don't really want it to sit there in a bot, or if a customer says, I need to talk to an agent, at any point they say that, it's going to actually interrupt that flow. It's going to then reach out to our assignment services and say, okay, what human should I send this to? And then we'll actually establish audio and SIP down to the customer's WebRTC station. So that way we can facilitate as much as we can with the bot. But again, we have that human-bot interaction. So if we need to pass that off to a human, we can easily do that within there. So with that, I'm going to pass it over to Darren really quick from eMite to talk about why they were willing to be our beta guinea pig for this. And then I'll come back up and we'll actually walk through the config and play some demos that we recorded.
So yeah, thanks everyone for turning up. I've flown in from Australia, so I've had a long flight, and I've come in for today. Thanks guys for having me. I guess the reason we're here is because eMite is it's an analytics platform that runs on Amazon in the cloud. It's true multi-tenanted. It's real time. It's historical. Provides KPIs and SLAs. But what eMite does is provides correlation, cross-correlation between different technologies. And I guess if you look at what these guys have done here in combining their technologies, it's a true end-to-end business process. But at the end of the day, the customers and the business, they want to know what's happening from their perspective. You set all this infrastructure up, but how do I know what's going on right now? How do I improve that business? And how do I give that information to the right people at the right time? So because eMite's multi-tenanted, you're able to share screens, dashboards, and wallboards across multiple users. And we're working with Pure Cloud and have been for, I guess, the last 2 years as their preferred real-time dashboard solution. So, their customers will run eMite across, multiple divisions, and every manager, every agent, and all the business units will have their own wallboard. So for us to give a true end-to-end story to involve the Lex, to be able to say, okay, so how many utterances were there, how many were successful, how many got handed off, so that you can actually improve the performance of the business. But then also bring in information from your sales system, so from Salesforce or your service management platform from ServiceNow or from whatever tool it is, to be able to give that true end-to-end visibility to the people that really need that information. So from our perspective and from our customers, you can do historical reporting, but you also need real-time information. You need to be able to see what's happening right now. You need to be able to deliver KPIs that are specific to the user, and then be able to change dates and drill down. So I guess that's the story that eMite's adding to this, and that's why we were really keen to get involved, because we're already working with Pure Cloud. We really like the Lex technology, and because eMite does run on the cloud or on-premise, once we build the integrations for Pure Cloud, build the integration with Lex, it's basically reusable. So whatever we're building for one customer is available to every customer. So the dashboards, the wallboards, and SLAs and KPIs, once you've done that integration, that visibility will be made available straight away to every different customer. So thanks for your time, and I'll hand back over.
Awesome. So again, I'm in product, so I'm done with slides. I'll let Harshal take that. And I want to show some actual configuration here. If I can get in my laptop. There we go. Awesome. So again, to make everything real, I wanted to actually walk through how we configured everything, how we set it up both on the Lex side, on the PureCloud side, walk you through those flows, and then we actually have a demo at the end I'll play of the actual call flows working. So this is working. We did turn off some of the numbers because being at Amazon, I expected people just to start calling it nonstop and just hammering the system. So, so we did turn off those. But what we did to start off with is we created a very simple bot. And when I say we, I created this as a non-technical person. So again, it goes back to that simplicity part of Amazon Lex is very simple. So we created one called eMite Support Bot. Very simple, unique custom name. So what we ended up doing is talking with Darren's team, and there's kind of three main scenarios that we wanted to solve. There's a fourth we're getting ready to solve here shortly, but three main scenarios we want to solve, which was people calling in to create a new ticket, people calling in to get what's the latest status update of my ticket, and people calling to say, oh God, we're down, help me please, please, please. So we kind of set up with those three intents, and those were our model to start with for doing this as a beta in the US. So if you look, what we did is we created three intents, so create ticket, emergency, and get ticket status. We then, Harshal talked about having some predefined slot information. We actually ended up having to create some custom slot information, which was a good thing we had to do because since we were looking at ticket information, which is a little bit different than a number, and some of these are more literal strings. So what we did was we actually went to some real tickets and went out and basically put in a bunch of training data under each of these areas so that it knew what to listen for. So that way, not only could someone call in, but they could actually call in and say a more succinct information on what's actually going on with their situation. So we went through and we did training on all these different pieces, and then also did some that are slot values so that we could actually make it easy along with synonyms because everyone talks a little bit differently. So we went through and put a large amount of training data in there, and then made sure, as Harshal showed earlier, make sure we mapped our slots. So we got all the slot information. We can pass that all. Emergency just listens for emergency information and basically passes of what service is broken so we can quickly get that to an agent. We don't want to sit there and keep prompting you for information while you're actually having an emergency. That's not going to make you happy. And then ticket, get ticket number. So pretty simple. And then for us, the way that customers will turn this on is we actually will our goal is to make it very, very simple. So customers will be able to actually come in here, find the Amazon Lex piece. When we make this active, there'll just be an install button here. They'll be able to click, and immediately it'll install the actual integration with Lex and PureCloud, and then you'll just have to provide an IAM role for Lex to actually go out there. Now, one note, you have to do Lex and Poly, I learned. So make sure when you go do that, and we'll have a whole document on how to do it. And then, once you get in, it's very simple. So what our teams did is as soon as you actually get in and have the Lex integration set up, you'll actually get a new toolkit. So in here, there's actually a new toolkit item just called Call Lex Bot. You pull that down into your call flow, and all you have to do is pull that down. There's a drag down. It'll hit the Lex API, show you what bots have been published and available within your service, and then you just choose one. It then automatically will map all intents as different areas of the call flow, and it'll actually provide all the slot data so that you can map variables within the actual PureCloud side to those slot values provided back by the Lex team. So made it very simple from that. So our goal is, again, simplicity. We want people to be able to easily use this. So when you pull this bot over, all I had to do is choose the bot name and the bot alias, and immediately it creates all these sections here, which I can hide if I want you to keep it a little bit simpler. So if you want to do a bot with 7 or 8 intents and you want to start building out more complexity, you can do that. So in here you can see we have the create new ticket. That was one of the intents, to get ticket status, and the emergency. So again, made it very, very simple from that perspective. So with that, I'm going to actually see if I can play the demo for you really quick. I apologize, it doesn't look the best on the screen, but so what we'll do here is we'll walk through all three of those use cases I just showed you.
Thank you for calling the EMI support line. I was unable to identify your account from your phone number. Please enter your registered support phone number. Thank you, Jack Nichols, for calling the EMI support line. How can our team help you?
Open a new ticket.
I can help you with that. What type of assistance do you need? Examples are incident, question, or services.
Question.
What priority should I assign to this ticket? High, normal, or minor?
Minor.
What type of service do you need assistance with?
Agent dashboard.
Please provide a short description of your problem for our technician.
Delays in agent metrics.
Okay. Please verify that you would like to open a new minor priority question ticket.
Yes.
Ticket number 1807 was created for you. Please check your email for updates and to add additional support details on this ticket.
So that was the actual ticket that was created.
Thank you, Jack Nichols, for calling the EMI support line. How can our support team help you?
I need to check on my ticket.
What is your ticket number?
1807.
Please confirm that you are calling about ticket number 1807.
Yes.
Your case number 1807 with priority was updated at 2017-11-22-TON:18:02Z with the note. Jack, can you tell me what metrics are being delayed and the duration of the delay?
Oops.
17.
There we go. Technical difficulties.
Your case number 1807 with priority was updated at 2017-11-22-TON:18:02Z with the note. Jack, can you tell me what metrics are being delayed and the duration of the delay?
So for some reason there's missing video there, but so basically went out, I put notes in there, called in, and immediately read that back.
Calling the EMI support line. How can our support team help you?
I'm having a system down emergency.
What EMI service is currently impacted?
Agent dashboard.
Transferring you to our emergency support.
So immediately when it understands the intent as an emergency, it transfers me out and gets there. You know, and so to give you an idea, I mean, this was all done actually from a conference room using a WebRTC phone in Japan, calling all the way back to the US. So, you know, this is actually up and running and working, you know, and verified, hence why at the end you saw it said Tokyo, Japan on the number there. Great. So with that, I'm going to hand it back to Harshal to kind of talk about some of the detailed technical pieces.
Sure. Thank you, Jack. All right. So In the next few slides, I want to cover some of the building blocks that made this integration possible. So when we looked at this integration, there are a few items. One, we wanted to make it possible so that the IVR workflow could reach out to the Lex Chat Bot and get the hierarchy of resources, whether it was the bots, the intents, or the slot types. So that was one piece. Second, we wanted to put a permissions model in place so that this was done securely, and only the IVR workflow only the IVR workflow could reach out to the chatbot to either get the resource hierarchy or to even connect. The third piece was related to connecting to the Lex Chat Bot, and this is passing the audio or the text utterances to the Lex Chat Bot, and we'll talk about that. The fourth area was call flow execution, and this is a piece where you exchange information. So if you notice in Jack's demo, there's a point where the bot is able to recognize the phone number and say that, okay, I'm not able to look you up based on the phone number that you're calling from. Can you please provide me the registered phone number? So there's an exchange of information that happens between the IVR system and the chatbot. So we'll talk about that. And finally, integration with other services, including Zendesk, including eMight, and Genesis. So those are the building blocks that I want to highlight. So the first one is the NLU Model Definition. A quick note about Lex. The way Lex arranges or defines the resources is as a hierarchy. So you have a hierarchy where you have bots that contain intents, and then the intents contain the slots. So when you want to populate these resources into a IVR workflow, the way you do it is, again, through a hierarchy of calls. So you start off with a get bots call to get a list of all the bots in that account. That's followed by a get intents call to get a list of all the intents inside that bot. And finally, a get intent call to get a list of all the resources, including slots, in that intent. So that's what you do to get all the resources transferred to the IVR workflow. Now, this is really useful because depending on which intent was triggered, whether it was a create new intent or the emergency intent, you would have a different way of routing that flow, that call into the flow. Maybe it goes to a low priority queue if it is just updating a ticket, but it's a high priority queue if it is an emergency intent. So those are the that's the logic that you have to consider at this point. Next, the permissions model to make this possible. So when you're accessing the Lex Chat Bot, it should only be the IVR workflow account that should be allowed to do so. How do you accomplish that? So you set up an IAM role, which allows the IVR workflow account as a trusted entity to access the Lex Chat Bot in a read-only mode. And we have granular access for all our APIs, which makes this possible. And once you've defined that IAM role as the first step, the second step is to make sure you deny access to everyone else. And that's the permissions policy that you're setting up. And finally, you test this role using something like AWS STS Assume role, where you test that the configuration that you set up is indeed what is happening. So this is the IVR acceptance piece, or the permissions policy piece. The third area here is connecting to the Lex Chat Bot. Now with Lex, we've made it really easy to connect to the HTTP endpoint and send audio. So you don't have to convert speech to text separately and then send the text to a chatbot. You can just use a single API, which is the post content API, to send across the audio. Lex will parse it, convert it into text, and provide the response. So what you see here is actually what goes on the wire. We also provide SDKs, so you're kept away from even this complexity of the request and the response. On the way back, when the bot responds, you want to convert it to voice. And like I mentioned earlier, this is the integration with Amazon Polly, where the text response is converted into speech response. And that's what you see here, where one of the voices is selected on the Lex dashboard. The fourth area, which I think is fairly important, is exchange of information. And like I mentioned in Jack's demo, the phone number was the one that was being transferred from the IVR to the Lex Chat Bot. And that's what you see here as a phone number highlighted over here. So the phone number is transferred as a session attribute to the Lex Chat Bot. Think of session attributes as out-of-band data. If you were to use web terminology, they're almost like web cookies, where you can use them to transfer information between the client and the server side. On the way back, again, you can use session attributes. In the call flow that Jack executed, you had the ticket number, which was being transferred from the bot back to the IVR workflow. So really useful. We have session attributes today. Also, we have something called request attributes. It's not used as part of this demo, but the difference between session attributes and request attributes is session attributes are persisted at every turn of the conversation, whereas request attributes are not persisted or not stored. So for somewhat more sensitive information, you might want to use request attributes. Both session and request attributes can be encrypted and can be decrypted based on keys of your choice. So that's something to keep in mind. And finally, integration with other services. So Lex natively integrates with AWS Lambda, and through Lambda, you can integrate easily with other services, AWS services as well as non-AWS services. So one of the examples is you can integrate with CloudWatch, you can integrate with DynamoDB on the AWS side. In the broader ecosystem, you can integrate with the CRM software, for example, with Zendesk, and that's how we integrated with eMight as well. So that brings us to the end of our presentation. We'll open it up for Q&A, but very quickly, what I wanted to summarize this as, with Lex and Pure Cloud, the contact center workflow is really simplified. We are bringing artificial intelligence in the hands of all the developers. Human touch is critical with AI. Jack, you want to add to that?
Yeah, no, I think, as you saw, we wanted to be able to integrate AI along with human touch. So you need to be able to have both those solutions be able to hand off seamlessly to each other. We see lots of value in that.
Yes. And we have a few resources online if you'd like to review them offline, or if you have any questions, please let us know. Thank you.
Thanks, everyone.
Questions, comments?
Any questions? I can't see anything.
All right. In any case, we are, yes. Sorry, what's the question? Yes. So the question is, can we integrate with other languages? So currently, Lex supports only US English, and that's the one here. Yeah, so UK English is pretty high on our priorities, and that's something that they're planning on 2018. Yes.
English. I think there's a question over here. Oh.
Sorry?
Is Lex HIPAA compliant?
Okay, the question is Lex HIPAA compliant? So currently, Lex is not HIPAA compliant. That's something that we are looking into as well. So we store the data on our systems. Yeah, but with Lex, you're always in control of your data. If you choose to, you can delete the data.
There's a couple questions over here.
Yes.
So you basically doing all the integration through API calls. So you get the text to speech.
Yep.
You get it as a
an audio. Yeah, we get an audio stream back, and that's what we play out. So it's actually streaming when it's talking to Lex because it's using the Poly. And then I didn't mention it, but up there, if you notice, we're actually using Poly too on our side. So we have some integration there to be able to feed that back and get the audio files from Poly.
So it's not an external IVR, it's purely APIs.
It's purely APIs, yes. Yep.
Right?
Any other questions? There's one.
As part of Lex, can you provide your own audio prompts instead of using Poly?
Yes, so there's a way to do that. So with Lex, you can do a combination of speech in and text out. So we support all the 4 combinations. So to accomplish something like what you just described, you would do speech in and text out, and you take the text and feed it to your own text-to-speech engine, which is different from Poly.
Yeah. So like we could have, on our side, we could have actually just taken the text, and we have a TTS engine we could have fed that into if we wanted to. But we wanted to keep the voice consistent. Correct. We wanted to keep the voice consistent, so it didn't change. That's why we used the Poly voice there, but we could have fed it into any any TTS engine, or even recorded prompts, for that matter.
Yes.
If you want to bootstrap a dialogue or an interaction from within your
The call when it's going through Lex.
the initial prompt.
The initial prompt you can barge in on. That's right. Yeah, you can. But once it's in Lex, that conversation is managed by Lex.
Yeah.
You're facing the same problem.
Yes. And on the Lex side, we don't have budget capabilities yet, but we are planning to support a feature in the early 2018 where something like that would be possible. Yes.
More. Yeah, good questions. Good.
Does Lex have any conception of a default intent? If it can't match an utterance to any of the classified intents that you created, can it just default to something, or is that where it's kind of dropped out? In your case, you just sent it through.
Yeah.
Yes. So one way to do that would be we monitor the state of the dialogue, and if the dialogue state is failed, meaning Lex is not able to recognize it, then you can transfer the call to a human operator.
So there wouldn't be any capability for it to not specifically register it as one of the classified intents, but still somehow pull slots out of it. Say, this looks important, or this is something that matches in some way other slots that you've had elsewhere, but it doesn't necessarily match this classified intent.
Yeah. So currently we have something called error handling, which will play a prompt, but it will not transfer the call to, let's say, a different part of the workflow. We are working on a feature where, as part of error handling, we'll call a Lambda function. Once we have that, the Lambda function can do exactly what you're saying, transfer the call.
It doesn't seem to be showing up there, but so I don't know if you saw when we pulled ours over, it automatically creates a failure intent underneath there, so that if Lex does provide that failure back, you can then route. So like in ours, if it fails, it either routes to a human agent or to an old IVR call flow.
So something that Jack kind of went over really quickly, but it's really powerful, is the fact that you can use
There you go.
attributes in Lex. So say you're in the IVR, collect a whole bunch of information about the customer already. You can actually bootstrap Lex, so it doesn't have to prompt you for any of that information, or just fill the slots in. And so it'll only ask you a couple questions before it comes back.
Yeah, so there you can see the failure there at the far right, so it automatically maps one of those, so to your point on the default, so that way you can then take that anywhere you wanted to.
Between Lex and the person itself, because
Yeah.
once it's in Lex, it's all the audio processing.
Yeah. And you have access only to the text, or do you have access to the audio as well?
So currently, it's only access to the text, but we are planning to do a feature where you'd be able to export the user utterances to an external data store such as S3.
No, yeah. No, we can't record the IVR because whenever we're doing the capturing of the audio,
It's hairpin through our media services.
into our media stack.
Yeah,
Yep.
that's on you guys, not on us.
Correct.
Correct. Yep.
But we
Yes.
capture the utterance, we endpoint it, and then we submit it to Lex for processing.
We have a question over here. You've been trying to ask a question for a while.
Yeah, this is another but we just migrated to Genesis like a month ago, so I was just curious, and you may have mentioned it earlier, but I think I might have missed it. This is not available yet.
So this will go beta at the beginning of the year for customers that want to try it out early, and then we'll be coming out sometime in Q1 as GA. Right, Dev? Yeah.
There's one more level before we go to GA that Rod's probably counting on.
Yeah. We do a beta, which is a, kind of very test at your own will. And then we do what's called limited availability, which means it's pretty stable. There's a couple known bugs. We'll let you know, and then you can use it. So and that link that was up there, if you go to Genesis site, you can sign up, and we'll actually be sending out a copy of the video, configuration files. We're going to do kind of a best practices based on some of our learnings from setting this up, because we definitely learned a lot as going through this and kind of putting it together to guide our customers to it.
Supported reload, when you post that utterance to the API endpoint, is that only 16-bit WAV files, or does it support like G729 or things like that?
Currently, we support PCM, channels, and we support a couple of other formats I can't recall them right now. We also support G7.
But they support both 8 kilohertz and 16 kilohertz, which is important because for telecom, 8 kilohertz is,
G7.
but G7 level, yeah. Cool.
Awesome.
Thank you very much, guys.
Oh,
Any premise plans for Genesis?
for integration to Lex, we're starting off with Pure Cloud, cloud to cloud. They'll definitely be looking from the Pure Engage side on creating an adapter. They use a lot of MGCP today, so they need to be able to do the REST calls on it. Thanks, everyone.